All right, today we're cracking open a piece of tech that sounds like it's straight out of science fiction. We're talking about a machine designed from the ground up to be, well, literally unclonable. So let's dive right in.
I mean, really think about that for a second. You know how digital stuff works, right? Anything can be copied perfectly, infinitely. So how in the world can a piece of software prove it's the one and only original? It's a totally mind-bending problem, and that's exactly what we're digging into.
Okay, so here's our game plan. We're going to start with a simple app, then peel back the layers to see its heartbeat, its anti-cloning gate, how it talks to the real world, the whole shebang. By the end, you'll get how this thing pulls off what sounds impossible.
So where does a journey into an unclonable machine even begin? Well, it's not in some giant abstract data center. Nope, it's right there in the palm of your hand.
On the surface, it all kicks off with something that looks pretty familiar, a secure wallet app, probably on your phone. It's kind of like the friendly face of a much more complex machine lurking just underneath. And yeah, the app does all the stuff you'd expect, right? It stores your digital identity and assets, it uses Bluetooth to find other devices, scans QR codes for transactions, you get the picture. But here's the thing, don't let that familiar interface fool you. All of that is just a window into this incredibly powerful, self-contained engine, a core that's written in Rust, which tells you they're serious about performance and security.
All right, let's go deeper now. We're getting to the core of this machine, to see how it literally builds its own reality. And it all starts with how it sees time. And trust me, this isn't just some boring technical detail. This is the foundation for everything else.
So check out this contrast. On one side, you've got normal software. It runs on what we call wall clock time. You know, the actual time on the clock. It's messy, it's unpredictable, it's different on every device. But this machine, it throws all of that out the window. It runs on its own internal rhythm, something called logical ticks. Just think of it like a perfectly steady, metronomic heartbeat. And that heartbeat makes its entire world perfectly predictable.
And this is not just a suggestion, you know? It's a strict, unbreakable rule buried deep in the source code. This comment here is basically a commandment. No system time or Unix epoch anywhere. The system is literally forbidden from asking the outside world, hey, what time is it? It has to live completely within its own timeline.
And that brings us to this absolutely crucial concept, determinism. Because it controls its own time, the machine creates this, like a perfectly sealed digital laboratory. If you give it the same starting point and the same inputs, it will always produce the exact same output. Every single time. No exceptions. And that perfect predictability, that's the master key to all of its security.
Okay, so now we get to the absolute heart of the matter. How does this thing actually prove it isn't a clone? Well, it does it with a feature that honestly sounds like it was ripped straight out of a spy movie.
Its secret weapon has this wild name, Random Walk Memory Interrogation. It's a ridiculously clever process that lets the software create a unique fingerprint of the physical hardware it's running on. We're talking about a signature that is next to impossible for a fake, a clone, or an emulator to replicate.
So here's the breakdown of how it works. First, the machine creates a totally random path through your device's physical memory. Then, and this is the genius part, it measures the precise time it takes to access each one of those memory addresses, down to the nanosecond. The best analogy is like shouting into a canyon and timing the echo. The unique shape of that canyon creates a unique echo, right? A recording of the shout won't fool the physics, and a different canyon will give you a different echo. That's what's happening here. This machine is listening for the unique electronic echo of your phone's physical hardware.
But, you know, this incredible physical fingerprinting trick doesn't work in a vacuum. It's all wrapped up in layers upon layers of seriously advanced, even future-proofed cryptography to make sure every single piece of data is locked down tight.
Just take a look at the arsenal it's working with. You've got Blake 3, which is all about being ultra-fast and secure for data integrity. Then there are Merkle trees, which are a super efficient way to prove something's true without showing the whole database. But here's where it gets really wild. Sphinx Plus and ML-Chem. These are quantum-resistant algorithms. Let me say that again, quantum-resistant. That means this thing is being built to defend against attacks from the kind of supercomputers that don't even exist yet. It's mind-blowing.
So, okay, we've got this perfect, sterile, deterministic world inside the machine, but it still has to live in our world, which is messy and unpredictable. So how does it interact with the outside without getting contaminated? Well, it does it through a very special kind of bridge.
That bridge is called the Platform Boundary Interface, or PBI for short. And get this,
The code itself calls it a hard boundary. It really is like the airlock on a spaceship. It's the one and only way for information to get in or out, and it meticulously inspects and sanitizes every single thing that tries to pass through.
Yeah, the PBI's job is absolutely critical. It takes all that chaotic stuff from the real world, like you tapping the screen or data coming from the network, and it translates it into the strict, ordered, predictable language that the core machine understands. And check out that last point, because it's super important. It's a bytes-only format. There's no room for interpretation. This is a huge security feature that shuts down a whole class of clever attacks that try to exploit ambiguous data.
All right, so now we've got these perfectly isolated, totally unclonable machines. So how do they talk to each other? They don't go through some central server. Nope, they talk directly, peer-to-peer, using what's basically a carefully choreographed secret digital handshake.
And it all happens using Bluetooth Low Energy. So one device basically puts up a flare, advertising it's there. A nearby device sees that flare and starts a connection. Then comes the crucial part, the identity exchange. They swap this tiny little package of data to prove who they are. Only when they've both verified each other's identities can they start actually communicating. And they do that by breaking up big messages into smaller chunks to send them reliably.
And that little identity package, it's exactly 64 bytes long. Not 63, not 65, 64. 32 bytes make up its core identity. They call it a Genesis hash, and the other 32 are for its unique device ID. See? Nothing is left to chance here. It's another part of this precise deterministic protocol. Every single one of these machines speaks the exact same ultra-secure language.
So, we've peeled back all these layers, we've gone deep into the architecture. What does it all mean? What have we actually found here? Let's put all the pieces together.
What we've just decoded isn't just another secure app. It's a whole new kind of digital entity.
It's deterministic, which means it's perfectly predictable because it runs on its own internal clock. It's physically bound to the hardware it's on, thanks to that memory fingerprint, which is what makes it unclonable. It's isolated from the chaotic outside world by that strict PBI airlock. And it's securely connected, talking directly to its peers over a verified encrypted channel.
And all of this leaves us with one massive question. If a piece of software can cryptographically prove it's a unique physical original, what does that mean for everything? For digital ownership, for secure voting, for how we prove who we are in a world that's about to be flooded with AI and deepfakes? The future of trust might just be locked away inside this unclonable machine.